This video was originally intended to talk about how reducing methane emissions is the low-hanging fruit to give us some margin in the fight against climate change. However, explaining this without talking about what greenhouse gases are, how they interact with our atmosphere, or how the greenhouse effect in general works, would have been a bit much. Therefore, in this video, we'll stick to a limited introduction to the greenhouse effect before we dive into the specifics later on. We'll discuss the greenhouse effect, we'll touch on absorption of the infrared spectrum, and talk about the three major greenhouse gases in our atmosphere. The greenhouse effect is actually relatively easy to grasp. Incoming sunlight hits our planet and warms up the atmosphere and the globe, which in turn emits longer wavelength infrared radiation in the form of heat. That sounds complicated, but that longer wavelength is basically what heat vision cameras see. Some of this heat remains trapped and heats up our globe, some of it goes back into space. Space! By natural causes, this is how our planet has become nice and habitable. Without this effect, our third rock from the sun would be a cold ball of minus 18 degrees Celsius. However, this natural effect gets upset when we add more greenhouse gases into the atmosphere than the natural balance can cope with. More greenhouse gases in our atmosphere means a warmer globe with all consequences thereof. Normally, such changes take thousands to millions of years, but going through these changes at a high pace isn't something the natural processes or even our civilization are equipped to handle. I briefly mentioned infrared light and wavelengths. We won't go too deep into this, but suffice to say that much like we can see through a glass window with visible light, while it behaves like a mirror for infrared, gases can also behave differently for visible light versus other parts of the light spectrum. Ozone, for instance, is very good at stopping short wavelength, high frequency light waves, which you'll probably know as ultraviolet or UV light, but lets the rest of the spectrum pass without any questions asked. Similarly, greenhouse gases mostly stop infrared light on the other part of the visible spectrum. The important difference is that long wavelength infrared light is what our atmosphere and Earth emit by heating up. Absorbing these wavelengths means trapping energy that was allowed in at first, but is now no longer allowed to leave. But who are these greenhouse gases and what do they do? Greenhouse gases was first documented by Eunice and Foote in 1856, and further research was done by John Tyndall in 1859. Unfortunately, history rarely properly credits female scientists for their discoveries. What Foote observed was that jars with certain gases warmed at different rates when exposed to sunlight. This experiment is relatively easy to reproduce, and we will do so properly in a later video. In the meantime, here's one demonstrating the effect rather nicely. You can also find it in the description below. Further research taught us which gases absorb how much radiation, allowing us to quantify their global warming potential, with CO2 being the measuring stick to quantify the impact of other gases. This way we can quantify that methane is about 25 to 30 times more warming compared to CO2 over a 100-year period. The combination of more gases absorbing more energy over different parts of the spectrum means more heat is trapped instead of emitted back into space. Now we know how those gases make up the greenhouse effect, so let's look at how we as a civilization affect this. The gas with the largest warming impact in our atmosphere are methane, CO2 and, oddly enough, water vapor. They're by no means the only ones, but they do make up the top three. Of these three, the increased concentration of CO2 and methane is due to our own emissions. We've been burning fossil fuels relentlessly since the Industrial Revolution without offsetting those carbon emissions through either natural or man-made means. Water vapor is a different story. Water vapor has the single largest contribution to global warming, but its concentration is dependent on the temperature of the atmosphere. Man-made water vapor emissions don't really do anything. If there's more water vapor than the air can hold, it simply makes clouds and rains out. Temperature is the only way more or less water can be absorbed by the air. This puts us in a bit of a pickle. Our carbon emissions in the form of, among other gases, methane and CO2, heat up our atmosphere a bit, allowing it to absorb more water vapor and subsequently heat up more. Water vapor is effectively amplifying the heating done by carbon emissions. But these carbon emissions do remain the root cause. During the edit, I found that the explanation about how water vapor interacts with the atmosphere was a bit short, so a few extra words. Water vapor gets into the atmosphere by means of evaporation, rivers, lakes and mostly oceans. The warmer it gets, the more evaporation occurs, and also the higher the concentration of water vapor into the air, which in turn makes it all warmer, more evaporation and so on and so forth. All in all, this means that water vapor has a contribution of about 50% of all global warming, purely started by our own carbon emissions. Now, this is purely the gist of the matter. For more info, please do check out these two light-hearted videos on the subject by people with actual doctorates in atmospheric physics. Now, while most of the warming is done by water vapor, we can't change that ourselves. The only way to bring that back down, or at least stop it from increasing any further, is to reduce our carbon emissions. We have to stop burning fossil fuels for energy and transportation, both for CO2 as well as methane emissions, as leakages from mining and transporting coal, oil and gas are the second largest cause of man-made methane emissions after agriculture. Well, this video has gone long enough. We will get back to methane in a separate, dedicated video. In the meantime, if you have any questions or suggestions for future topics, please do leave them in the comments down below. However, for the time being, thank you for watching.
Space!